To be doing three problems today for today's homework on pages 444 and 445. I'm going to do problem number 6 from graphing, problem number 9 from substitution, and problem number 12 from elimination. So I'll start with problem number 6 first. So this is the one for the graphing section. So we have two linear equations in a system, and all of these will have two equations in a linear system. They have that in common, so the only thing that's different is the actual solution, how you get to that point of intersection. So in graphing, you need to graph each individual equation by first putting them into slope-intercept form. So I have two different equations. The first one, x plus y equals to 3, and I want to isolate for y to put it in the slope-intercept form, which, if you remember, looked like this: y equals to mx plus b, where m is the slope, b is the y-intercept. So I'm going to subtract x from both sides. That gets me y all by itself, which is the desired result, and 3 minus x on the right side. So now I can get my slope, which is whatever is next to the x. In this case it's a -1, though you don't really see it, but it's a -1. And my y-intercept is whatever is by itself, 3. Perfect. So I got both my slope right over here, and I got my intercept right over there. So now I'm going to solve the second equation, which is x minus y equals to 5. Again, my goal is to isolate y, so I'm going to subtract x from both sides. I get -y equals to 5 minus x. Now here I need an additional step because y is negative. I need it to be positive. I'm going to multiply everything by -1. So here it becomes a positive y. Here I have to distribute that negative to both members of the parenthesis. So -5 plus x. Again, my slope is going to be whatever is next to the x, and that's a 1. And my intercept is going to be whatever is all by itself, which is -5. Now that I have those two pieces of information, the slope and intercept for each equation, I can graph them, and that is precisely what I'm going to do next. Again, graph paper is just so useful, and so is a ruler for getting these graphing solutions. So let's go ahead and make a coordinate plane. And then let's go ahead and graph. So the first equation, I'm going to graph that one in the black. The intercept is +3. The slope is -1, which is the same as -1 over 1. So down 1 over 1. So down 1 over 1, down 1 over 1. And that's enough to get us going. Oops. Perfect. So that was the first. The second equation, the intercept is -5 and the slope is 1. So the intercept is way down here on the y. 2, 3, 4, 5. It's our starting point. Slope is 1 over 1, so up 1 over 1, up 1 over 1. So up 1 over 1 here, up 1 over 1 here. Graph them. And the point of intersection is right over here, which in this case is x at 4, y at -1, because x is at 1, 2, 3, 4, and y is at -1. And that's my solution to this particular system, and I can always check that my work real easy by plugging it back into both. So if x is 4, y is -1, from here it will be 4 minus 1 equals to 3, 3 equals to 3, check. Over here it's going to be 4 plus 1, because minus 1, it's a double negative, and 5 equals 5, check. So that was number 6. I'm going to go ahead and move on and get to number 9, which is the next problem we'll do. This one is done using the substitution method. So it's going to be simpler and shorter because graphing is always the longest of the 3. Substitution typically isn't too bad, although it can be a little longer than elimination. 2x plus y equals to -15. Y minus 5x equals to 6. So here we have to choose which variable we're going to substitute for, and then which equation we'll choose. Y is all by itself in both equations. Honestly, I don't really see any of them being a problem. The top one or the bottom one. I'm going to go with the bottom one just because. But I'm going to be using y because y doesn't have a coefficient in both. So y minus 5x equals 6. So I'm solving for y, so I'm going to get rid of this x by using reverse operations. Equals to 6 plus 5x. So now I'm going to substitute this y the solution to y into the y of the other equation, the one that I didn't choose. So it'll be 2x plus 6 plus 5x equals to -15. And in the blue, that's our substituted portion. So now I just need to combine my common terms, like terms. 7x plus 6 equals to -15. I'm just solving for x here, so I'm going to subtract 6 from both sides. That's going to be -21. I'm going to divide both sides by 7. And x is equal to -3. So now that I have that, I'm going to take this x, or the solution to this x, and substitute it into either of the two original equations. I think the x here is the best candidate. I think that's a little bit of a simpler substitution. Again, that's just what I think. You could have chosen the bottom one. So 2 times -3, which is our substitution right there, plus y equals to -15. Sorry, barely squeezed that in there. So 2 times -3 is -6 plus y equals to -15. Add 6 to both sides. And we get that y is equal to a -9. And that's it, we're done. We have our x, we have our y, we get our order set. X goes first, y goes second, -3, -9, done. So that was the substitution method. Again, you chose a variable, then you chose one of the equations, and you solved for that variable. Once you got the solution to that variable, you plugged it into the other equation, the one that you didn't choose. So I can't plug this back in here because that's the original equation that I chose. So I plug it in for the y here, solve for x, I get x. Then once I have a concrete constant for the x, I plug that back into either of the original equations, I get my y, and that's the solution. So last problem we're going to do is 12. This one is elimination. The easiest method if it works, right, if it works. Sometimes, and we'll cover that in 7.4, it doesn't quite work out where you have to modify it, and sometimes even with modification it just doesn't work out. So elimination is great when it works. If not, you can always fall back to substitution. Now, before we even eliminate anything, the x's and the y's and the constants all have to line up. In this case, they don't. The y is right on top of the x, the constant is on top of the y, and so on, and they're on different sides of the equation. I need to rearrange one of these equations to make it look like the other one. I think I'm going to rearrange the top one to make it look like the bottom one. So I want x and y on one side, the constant on the other side. So x and y here, constant there. So I need to move that x over here. So I'll rewrite that top equation. So I want the x from here to here. I can just add 3x to both sides. Done. So now I have 3x plus 4y equals to 11. I just literally move the x by taking it off from here and putting it over there by using reverse operations. I'm going to rewrite this equation right on the bottom of it. Again, it doesn't really matter if they go on top or bottom. But take a look now. Everything matches up. X on top of x, y on top of y, constant on top of constant. Before it didn't match up. You cannot eliminate until everything is on top of each other. Now I can eliminate. Adding or subtraction. Here subtraction will be best because 3x minus 3x will get rid of the x, and if I try to add, nothing was going to get eliminated because 3x, plus 3x at 6x, 4y plus 2y that's 6y, no variable eliminates, so subtraction is going to be what we use. 3x minus 3x, 0. 4y minus 2y, it's going to be 2y. 11 minus a negative 5, that's a double negative, so it's 11 plus 5, which is 16. Divide everything by a 2, and y equals to an 8. Now we're not finished yet, because we got y, and now we need to plug that y into one of the original two equations to get x. It doesn't really matter which one you choose, the top one, let's go with that. So I'm going to plug this in there. So it'll be 4 times 8 equals to 11 minus 3x. So 4 times 8, that's 32, equals to 11 minus 3x. Then I am going to subtract 11 from both sides. So that's going to give me a 21, positive 21 on this side. Here it's 0, equals to negative 3x. Divide both by negative 3. Simplifies to 1. X equals to 21 divided by negative 3, which is negative 7. So now I have both y and x. I just put them as an ordered pair. X goes first, y goes second, and I have a solution to my system. I'm not checking my work here, but if you were to plug this into both equations for the x and the y, it should have worked out. I only check my work for the graphing because that one can be a little inaccurate, but it's still a good idea to check your work, or if the problem specifies for you to check your work, then you should definitely do it. So that was the homework, the 3 problems that I solved. Hopefully that helps, and have a nice day.